Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to help you out with number 95 in chapter 10 of the University Physics text, the OER text. So there is a bar or something like this connected by two strings. However, if you look at the picture, there's a pair of scissors cutting the string over here. So I've not even included it in the in my diagram here. Question says to find the tangential acceleration at the end and the midpoint. So the end being here and the midpoint being here. So the first thing you have to do is you have to decide on a method to analyze this. And we're not told about any changes in speed or any changes in height. So there's no change in speed. There's no change in h. There's no work done in this question. So this is just not a work energy question. Same thing with a motion analysis. We're not given any sort of distance, any sort of delta x or any sort of delta t. None of this is given. So it's not a work energy problem. It is not a question about motion either. That means this is going to default to Newton's second law. So what you need to do is you need to draw a free body diagram. Do not overcomplicate the free body. When you look over here, draw a picture of the system, put the force vectors in just like any other problem you would. There should be obviously a gravitational force in the middle, and there should only be one other force. Hopefully it's obvious where it is applied and what its direction is. Now the tough part about this is kind of understanding the motion or what's going to occur here. So this bar, let's talk about how it's going to behave. I'm just going to draw another picture of it. So my picture on the left would be the free body showing all the forces. I'm not going to do that because it's your homework problem. I'm just here to chat about how. I will talk a little bit about the picture on the right and talk about the acceleration. This thing is going to have an angular acceleration. This thing is basically going to start accelerating about this point right here. So we're going to have an angular acceleration, alpha. And that should be reasonably easy to find. Write yourself a Newton's second law equation summing torques about this point. Now, and talk about, why this point. Well, this rope here is not going to allow that point to move. Like this point right here cannot move in this direction, so it cannot have an acceleration this way. There are no forces acting horizontally on this in any direction. So at least just at the instant shown, that point right there is not going to move. So the acceleration just for an instant is going to be as if it's rotating about that point. So you can think of this as having an angular acceleration about that point. So what you want to do is write a torque equation. Sum of all torques equals I alpha. I would probably just do clockwise positive because that's the acceleration direction in the picture, and you're going to want to sum those torques about the red dot there. All right. The moment of inertia, if you don't know it, look it up. You'd want the moment of inertia of a bar axis through one end. Once you get the angular acceleration now, you can calculate the tangential acceleration of any point on the body. So this point right here, I'll draw this in red, would have a tangential acceleration this way equal to some distance times alpha. I'll put r1 here times alpha. The end point here is going to have a tangential acceleration in this direction, and I drew it larger because it is going to be larger, equal to this distance, which I'll call r2 for a moment, times alpha. The important thing to realize is all points on this body are going to have the same angular acceleration. So this alpha is the same for both of them. No point on this body would have a centripetal acceleration in this picture because centripetal acceleration is a v squared over r term, and there's no v yet. At the instant shown here, nothing's moving. These are just acceleration vectors. So again, the key, draw a free body diagram. The simplest equation would be writing it about the left end and just treat it like an object, like it's rotating right up around that point. And the reason we can kind of get away with that is because it's connected to this rope here. We know that this point cannot accelerate this way. That can't occur. And there's no forces here either horizontally. So they're at least at the instant shown, just for an instant, there's going to be this thing right here is not going to accelerate left or right either. So just for the instant shown, we'll treat it like it's rotating at around this point. So we're going to imagine the angular acceleration being clockwise around that point. and write your torque equation about that point. You're only going to have one force in that torque equation if you do it right. Right? And then the I, this moment of inertia, needs to be about this point here. So you look up the moment of inertia for a bar axis through one end. That should be enough to get this problem done. I hope it helps. Have a great day.